Let's explore the following circuit. We have a green LED in series with a 1K resistor from 5 volts to ground being powered by the end scope. A question that we have is how much current is going through the circuit. Specifically, how much current goes through the resistor and how much current goes through the LED. Well, they have to be the same because the current is coming from 5 volts going through the LED, through the resistor to ground. These components are in series. So there's only one current to measure. And then we want to know what are the voltages across the components. So what's the voltage across the LED? And what's the voltage across the resistor? Those will not be the same, but we know that they have to sum up to 5 because we're starting at 0 volts and we end at 5 volts. So the voltage across the resistor plus the voltage across the LED must be 5 volts. Now we can use the end scope to measure voltage. The inputs to the oscilloscope measure voltage. But in this case, the voltage isn't changing with time, so it's a little easier to read with our multimeter. So let's investigate how to use our multimeter to read the voltage and read the current. Note that it's hard to read the current with the end scope. The end scope only reads voltages. So if we wanted to know the current using the end scope, we'd have to read the voltage across the resistor and divide by its resistance to get the current using V equals IR. Okay, so let's look at our multimeter. This particular model has an on button, so let's turn it on. The probes go into COM, and if we want to read voltage, we want to go into the volt hole, and if we want to read current, we'd go into the milliamp or amp hole. In this case, we're going to guess that the amount of current we're reading is very small. Something around 5 volts divided by 1K is 5 milliamps, and probably a little less. So we're going to use the milliamp scale. So we're going to start by reading voltages, and then later we'll move over to the milliamp setting. So how do we read a DC voltage on the multimeter? We're going to turn over to this setting, V with some a straight bar and dashed line. So that means DC voltage. And if we're on the 200 M setting, that means the largest voltage we could read would be 200 millivolts. We know that we're in the range of like 5 volts here, so let's be able to read at least 5 volts. So we'll go to the 20 setting, meaning the largest amount we could read is 5 volts. So first thing we can try is we'll take our probes, and because we have the black one plugged into COM, that means it's the negative lead, so we know it's ground. And we'll we'll touch the other lead to the pin on the LED that's connected to 5 volts. And we see the end scope is outputting 4.96, about 5 volts. So the multimeter will show the voltage from the positive side to the negative side. So if we want to know what's the voltage across the resistor, I'll put the red side on the more positive side and the black side on the less positive side. And I see that this resistor has 3.01 volts across it. If I flipped it by accident, so I put the positive side on the grounded side and the negative side on the more positive side, now I get the negative version of that voltage. So we're going to try to keep our black probe on the more negative side to get our signs correct. So we have 3 volts across this 1K resistor. That must mean that we have 2 volts across the LED because we have a 5 volt supply. So from one end to the total end should be our total supply. And if I want to know the voltage across the resistor, I just touch either end of the resistor. If I want to know the voltage across the LED, I touch either end of the LED. Note that even though the probes of the multimeter are pretty sharp, I'd like to be able to like poke into the breadboard, into one of those holes. That is unreliable. They're not sharp enough to get in there. So you have to leave yourself a little bit of exposed wire to touch to be able to read something. Okay, so now we know the voltage across this resistor was 3 ohms. 3 ohms divided by 1K leaves us 3 milliamps. Let's verify that by reading the actual current using the multimeter. So now we're going to move our multimeter from voltage mode to current mode. And this is actually kind of unique to this multimeter. A lot of multimeters will only have 2 holes. So you could just leave it if you have that kind of multimeter, but we'll switch to this. Now we're going to be reading DC current. So we're going to move over Never turn my camera on. Come on, camera. Live view. There we go. Have to turn that off. Okay. We're going to be reading DC current, so we're going to shift over to this green area. We know we're going to be on the order of 3 milliamps, so I'm going to go to the 20 milliamp setting to make sure we have enough range. And now let's try to read the current, say, through the LED. So your instinct might be, well, I'll read it like I read the voltage. So I will touch the red side to the more positive side of the LED and the other side to the negative. And I'm reading 5 milliamps. And also note that as soon as I did that, the LED turned off. And then when I let go, it goes back on. And now if I tried to read the current by touching either end of the resistor, wow, I got a lot of current. The multimeter went over, and the LED got super bright. Why is that? Well, current goes through things. So if I give the current a path by touching the multimeter from, say, this end of the resistor through the current meter, so I'll draw that as the multimeter in current mode, back to ground again, I've put the multimeter in parallel with the resistor. So that means the current has the option, and it will go through both the resistor and the multimeter. The resistance of the multimeter is very, very low, so that means that overall a lot more current will go through the multimeter than the resistor. That is then going to decrease the overall resistance of the circuit, and we'll get way more current than we were supposed to. Likewise, when I put the multimeter in parallel with the LED, all the current went through the multimeter, none went through the LED, and that's why the LED turned off and we read too much current. So how do we read current with our probes on the multimeter? We have to open up the circuit. So this was the bad way. What we're going to do is we're going to take 5 volts to the LED, and it will go nowhere, and then the resistor will go to ground, and in between we will put the multimeter in current mode. That way the current that goes through the LED has to go through the multimeter and then through the resistor to ground. So that means I have to edit my circuit a little. So reading current with your multimeter is a little annoying. I'm going to break open my circuit. So now the LED is not on. And when I touch the multimeter to the LED and the resistor, the LED turns back on because now current can flow. And when I remove it, it turns off. So I'm going to show you what it reads. I touch the LED, I touch the resistor, the LED turns on, and we see 3 milliamps. So the important thing to remember when using your multimeter to read voltages and currents, to read a voltage, you touch either end of any component, and that's the voltage you get. Note that the red side should be on the more positive side to maintain the voltage convention. And then when you're reading current, you have to open up your circuit. You have to break it open so that it no longer works. Then you can insert the multimeter as if it were a component so that the circuit can be continuous again. The current has to flow through the multimeter, and then you get the correct reading. Now, let's talk about this one more time. Why is there a milliamp hole and an amp hole? Well, there's a fuse in the multimeter so that if you go over a certain number of milliamps or amps, this device will not break. Instead, the fuse will blow. There's a milliamp setting, so if you're if you're reading milliamps, you'll be in the M setting, and that would be the milliamp hole. If you're ever thinking you need to read something on the order of an amp, you would go to the 20 hole, and you would use the A. So you'd use the 20 volt setting and the A hole. Almost always, if this has been sitting around in the lab, I will assume that those fuses are blown, that somebody has been in the milliamp hole and read something on the order of amps, it blew out the fuse, and then it no longer works. So in general, it's a lot easier to read currents by using a series resistor and reading the voltage across it and using Ohm's law to calculate what current is rather than trying to measure it.